Hi, I'm Indiana Joe and welcome back to Blog Around Britain. Now, last week we discussed one of the first major types of fossilisation, which was petrification. This week we're going to be looking at a slightly different type, permineralisation. And I've actually got a permineralised bone here. It's quite heavy, it's a lot heavier than the bone that this animal would have come from when it was fresh in the animal, so there's a lot of minerals that have gone into it. But is that the same as petrification? Well, not quite. Do you remember this example we used last week? The fossil wood, the petrified wood. You could still see all the rings in it. It was full of minerals, but none of the actual wood was there. It had been replaced. Bit by bit, the minerals had gone inside and had replaced the wood that was there, and so now what you're left with is pure rock. An exact replica of what the wood was, but it's actually pure rock. It's been replaced by minerals. Is that the same as what has been happening here with this bone? This is actually the leg off of a mammoth. And this is a bit of an unusual mammoth leg because it's not the same kind of ones that you would find up in Siberia. When you find the frozen woolly mammoths like that, they're not actually technically fossils at all, even though they are preserved and even though they are quite old. The difference is those bones that you find are in exactly the same state as they would have been when they were in the animal, just like bones lying on the ground. The reason why they've managed to last so long is because they've been buried in permafrost, which is a mixture of sort of soil and mud, slushy kind of stuff that preserves it and holds it and stops it from being destroyed. But this has actually had quite a few minerals go into it. It's sort of a subfossil, if you like. But it's not just bones like this, subfossils like this, that you can find identical to it. You can find lots of other ones, including the most famous of all, perhaps the dinosaur bones. Now, we have quite a few dinosaur bones with me here. This is a vertebrae, that's a backbone. This is actually from down near the tail of a large iguanodon dinosaur from the Isle of Wight. We have also got some little bones from the Kemkem in Morocco, from the Sahara Desert in Morocco. These are from a Spinosaurus dinosaur. We have got some lots and lots of sort of chunks of bones like this from all different parts, and even some big paddle bones from, this is from one of the big plesiosaurs that would have been swimming around in the sea. So not technically a dinosaur, but pretty well close on. And you can even see, just sitting behind me here, I've got a big skeleton of a mosasaur, one of these big swimming reptiles. Now, what is going on here with these? What kind of fossilisation is permineralisation in fact? Well, it's actually quite strange and quite remarkable, because you see, with this bone here, the actual bone that was in the animal is still there. The very bone that held that animal upright is still there. The very bone that helped it swim along in the seas is still there. All that's happened is minerals that it's been buried in, sediment that it's been buried in, has gone in and infilled all of the little nooks and crannies and gaps and spaces in it, and it's covered over it, and it's permineralised it. Partially fossilised it, in fact. It still is regarded as a real fossil because it is quite old. It's quite heavy. It's full of minerals. It's preserving it for a long time. But the bone is still there. The actual bone that was in the animal. And that's generally true of most of these fossils. Things like the dinosaur bones, things like the Spinosaur dinosaur bones, things like these partially permineralised leg bones. The actual bone is still there. It's just been infilled and encased, permineralised. In fact, you can permineralise just about anything, and you can have a lot of fun with this. Earlier this year, I was setting up a research trip at a place called Harbour Hill, where you can see limestone forming really, really quickly. You can actually watch it form in front of your eyes. And we were finding lots and lots of leaves that had become permineralised. And we wanted to see exactly how long this would actually take. So in January, we got a soft, cuddly toy rat, and we hung it over the falls, and we waited. And we came back later in October last year, bearing in mind it was a very, very hot, very, very dry summer, and we discovered that the rat had become mostly permineralized. In fact, I'm planning another research trip there in a few weeks' time, and we should be able to see it completely permineralized. So quite exciting. But don't worry if you think that's not quite fully done, because we have got a fully completed permineralized specimen down here. This is actually our very own fossilized teddy bear. It is very hard. It is solid all the way through. It is from the Karlovarvary in the Czech Republic, and you've got these hot springs which are full of minerals, and it goes into the soft squidgy teddy bear, fills up with water, and the water begins to run through. And as the water runs through, some of the minerals that are in the water get left behind, and the teddy becomes infilled and encased in these minerals in under 2 weeks. So it is, by every meaning of the word, fossilized. Permineralized is a better, more technical term, but it is just as fossilized as the dinosaur bones are, just as fossilized as the mammoth bones are as well. So quite exciting. Now, as a little bonus feature, we're going to talk about one other type of thing which is usually sort of classed as fossils, but are not technically fossils or haven't technically had anything done with them. And these are what are usually what we call the Ice Age fossils. Things like I mentioned earlier about some of the mammoth bones. Now I've got some specimens down here. This is a vertebrate from a mammoth, from quite a young mammoth, and this is in exactly the same form as you would have found it in that young mammoth. It's got nothing filled in, it's had a little bit of a coat of paint over it, varnish, just to help keep it all together, because as soon as you take it out of the frozen place it begins to crumble. But apart from that, this is in exactly the same kind of state that it would have been inside that animal. It hasn't had anything done to it. It's been preserved in the mud and the ice, but it hasn't become permineralized, it hasn't become petrified, and it certainly isn't a cast or a mould. You can get lots and lots of fossils like these. These are some fossil antlers. These are semi-permineralized. They've had some minerals go into them as they've been sitting in the mud, but they're still not fully fossilized. You can see the antlers where they'd have gone on the top of the head. In fact, you can get really, really big antlers. In fact, this is from an antler from the Irish elk. You can see it's just a very, very tiny, tiny bit. You can see that sort of round bit there. That's where it would have sat on the top of the head. It would have had a huge plate that would have come out this way, and it would have had another huge, huge plate that would have gone out this way as well. Huge, great big pair of antlers for a massive, massive creature. And if you thought the antlers were big and the deer were big, you should have seen the cows. This is one of the great bison corn cores. Just a very, very tiny one. You can see the base there. It would have gone much, 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 much bigger up here. This is just a small little partial bit. But again, exactly the same kind of thing as what would have been inside the horn when that bison was alive. There really isn't any difference. It's just had a bit of a paint, a bit of a varnish to help look after it. So not technically a true fossil, but still considered one because of how it's been buried and preserved for that amount of time from that animal. So a little bit of a bonus for you. I hope that all makes sense, and I hope you've enjoyed learning about the different types of fossils. We've got one more very bonus special bit that we're going to talk about next week, which are the trace fossils, then we'll move on to living fossils the week after that. So I hope you enjoy that as well. And see you very soon.